Okay, in number 39, we have an initial value problem. They did give us one ordered pair that this original graph passes through, that being 0, 1, so we're going to be able to solve for to solve for C eventually. But first we got to separate our variables here. So all the y's are going to move left, so we will divide by a y on both sides, and that will cancel with that. I think I made that bigger than I needed to. We'll multiply both sides by dt. That'll get those to cancel, and I think that's about it, guys. So the left side now looks like it becomes, boy, again, it feels like this is just happening over and over again. That our left side is just 1 over y and a dy. Oh well. And our right side then looks like we have an e to the negative t power and all of that with respect to t. So, yeah, we've separated. Let's go ahead now and anti-differentiate both sides. So yet again, our antiderivative on the left is going to be the natural log of the absolute value of y. And that's going to equal, all right, same base, e, to the same power, negative t, divided by the derivative of that exponent. That'll put a negative 1 out in front of that. Now there would be a plus c here, and now let's switch to green, everybody. Now it's time to use the initial condition here to solve for c. So this now becomes the natural log of, and our y value here is this 1. I don't need the absolute value there because the absolute value of 1 is 1, equals, we have the opposite of e to the negative t power. Well, here's your t value here. So this is e to the 0, which is 1, and the opposite of that is going to be a negative 1 plus c. All right, only other tricky thing about this, the natural log of 1 is a value you guys should know. It's asking you e to what power is equal to 1, and that answer is 0. So 0 equals negative 1 plus c. All right, so we've got it, guys. C is equal to 1. That's a nice, easy number to work with. So let's go back to where we were just a moment ago. I'm going to switch back to blue here again. And now that we are armed with this new information that c is 1, let's see what we can do to come up with our specific solution. Natural log of the absolute value of y is equal to a negative e to the negative t and a plus 1 at the end of all that. We will exponentiate, oh, this just got ugly. We're going to exponentiate both sides right here, and boy, we have an e to a power that contains an e. That's kind of ugly, you guys. But all right. So the e and the natural log are just going to cancel each other out here. And so that left side is just going to be here. The absolute value of y is equal to, let me scroll here just a bit, guys. Come on, come on. All right. So the absolute value of y is equal to, and this is a mess. I think I'm just going to write this as the same base here, e, and for this exponent, I think I'm going to write it in the other order just because I think it's going to be a little bit cleaner. 1 minus e to the negative t power. And the only thing we would worry about next is to get rid of the absolute value here on the left, which we do by putting a plus or minus in front of the right temporarily. So y equals, so temporarily, I'll explain that in a second, there's a plus or minus here, and then it's an e to the 1 minus e to the negative t power. But I say temporarily because the initial condition that they gave us here, guys, y of 0 is equal to 1, is something we're going to have to consider to figure out which of these two possible cases it is. It's either positive or negative, but it is not both. And in a general solution, when there's a plus c or a times c in there somewhere, you can sometimes leave that plus or minus in your answer because it could be either one. But for an initial value problem, we know which one it is. So let's put 0 back in for t and find out if it's the positive or negative we need to end up with 1 for y. All right, guys, so if t is 0, this becomes e to the 0 power, which is 1. 1 minus 1 is 0. E to the 0 power is 1, and we wanted positive 1 right there, so it is the positive case right here, not the negative case. That was kind of my assumption when I went back and looked at the initial condition right there, and there we go. Now, if this had been a negative 1 then, well, first of all, that would have changed our c value, but second of all, there would have been a big negative out in front. But that wasn't the case, and this looks like our answer then to problem number 39.